One. So 2.1 is about inequalities. So we're going to look at the basics of inequalities. You've probably seen this already a little bit, and hopefully it's a little bit familiar, but some of the techniques and some of the example problems we do might be a little bit new to you. So we're going to take a look at an inequality. What is an inequality, first of all? What is it? Yeah.
It's when one side does not equal the other side.
Yeah. It's when things are unequal. Inequality, when one thing does not equal the other. Very good. What do we use inequalities for a lot? It's a really interesting point. What is it used for, Sarah? Comparing things, right? Comparing two things. If something's greater than another, or something's less than another. Now, anybody know word problems? What kind of word problems would you have inequalities in? It's difficult to find an application of this if you don't see it right away. What could word problems be involved in for different inequalities? Where would they be? What would the word problem say instead of, like, for example, right? If I said to you that every day, you sit outside and sell lemonade, and you're selling lemonade to save up money to buy a new CD or whatever, a new pair of sneakers. And you need to raise $50 for the new pair of sneakers. And the question is like, how many cups of lemonade do you need to sell to make $50? How would that problem change to become an inequality? Or how would it be related to inequalities?
You could say to sell at least.
Yes. What is the term again?
At least.
At least. Or another term, if you want less than or equal to, at least means greater than or equal to, right? What's the term that means less than or equal to?
At most.
At most. So if I said, how many cups of lemonade do you have to sell to make at least enough money to cover the cost of your sneakers? You might break even when you sell 50 cups of lemonade, but your answer would be 50 or greater, right? X is greater than or equal to 50 cups of lemonade. And once you make more than 50 cups of lemonade, every dollar after that is just profit, extra money for you to keep. So at least and at most are terms that we need to recognize for word problems for inequalities. Okay, so we're going to spend a few days on this topic. In the beginning, it's going to be basic inequalities, but when we get to word problems, we want you to recognize where they're utilized. We've got several different properties here. First, A could be less than B, A could be equal to B, or A could be greater than B. It's one of those three things. That's it. It's less than, it's equal to, or it's greater than. Okay, that's the only possibilities here. Now, the transitive property of equality also applies to properties of order. So, can somebody explain the transitive property there? And again, this is not transitive property of equality, it's of inequality. What's the transitive property mean there?
Like, if you say,
Give me an example.
X squared is taller than me, I'm taller than J, so X squared is taller than J.
Yeah. So this, in this case, is not when two things are equal, then equal to a third. It's more of like, okay, object A is faster than B, but object B is faster than C. Well, by default, A must be faster than C. It's just giving a ranking, right? Transitive property is a ranking. That's all it is. Which of the three is the biggest? Well, if that's bigger than the other one, it's got to be bigger than the third. Okay? How about addition property? What does that literally say? What can you do when you have an inequality according to the addition property? Well,
You can add the same thing to each side whenever you say.
exactly. Now remember that subtraction is adding the opposites. You can add or subtract the same thing from both sides. Multiplication property. There's a little, hiccup here. And some people know this one, some people don't. What's the hiccup for the multiplication property? Because you're seeing two conditions. The first condition is obvious, right? If A is less than B and C is a positive number, then you can multiply both sides by C and it's still true. But what's the second piece right here? Who remembers that from their maybe math class when they were younger? Sarah?
When C is less than 0, it's a negative number, so when you're multiplying a smaller number by a negative, it'll end up being greater than the positive number of the negative.
Okay, but how about simplify it for me, Sarah? You're right, simplify it for us.
So like if you use A equals 2 and B equals 3, and then C is less than 0, so it's like negative 1, then A times negative 1 would be negative 2, and then negative 3 times, wait, sorry.
I'm going to put the numbers up?
So is negative 3, so negative 2 is greater than negative 3.
Yeah, so what do you have to do in the end? What's the summarization? What does this tell us? Yeah, you got to flip the sign. Let's prove how this is true. This is what Sarah was talking about. Take a look. That statement is true. Everybody agree? Right? 2 is less than 3. It's obvious. But multiply both sides by negative 1 now. Is that true anymore? Where's negative 2 and negative 3? Think about a number line, right? Out of these two numbers, it's clear that negative 2 is bigger than negative 3 because it's further to the right on the number line. When a number is greater than another number, it just means it's further to the right. So negative 2 is bigger than negative 3, so this is not true. So as a result, what Sarah mentioned is we have to go ahead and flip the sign. Whenever you multiply by a negative, flip the sign. What else do you think is true then? If when you multiply by a negative, you flip the sign, what else is also true? Somebody else. Somebody else. Alex, how about you on this one? If you multiply by a negative, we have to flip the sign. So then maybe draw another conclusion.
When you multiply a negative number with a greater number, the greater number will become the smaller number.
Okay, that is true as well, absolutely. But what operation is related to multiplication? Addition and subtraction are related, like...
Division.
Yeah. So what can we generalize with that, you think? Use the same example. Right? When that statement is true, but if I divide both sides by negative 1, don't I get this again? Which is not true. So when I divide by a negative, what do I have to do also?
You want to change the sign.
Yes. Change the direction of the sign. Okay, so when multiplying or dividing, either one, by a negative, flip the sign. Okay? Flip the sign. All right. Now that we have those rules down pat, solve and graph. So you solve this like any other equation. Think of the less than symbol as an equal to sign. It should be, 10 seconds for you to solve this, right? Why didn't I flip the sign? I see negatives there. I divided into a negative. Why didn't I flip the sign, Chandler?
Because you only flip it when you're dividing by a negative or multiplying by a negative.
Very good. Only when you're multiplying or dividing by a negative, not into a negative. Do you see that? So I can divide by positive 3. I don't flip the sign because this is positive. Had this been the negative over here, and this had been positive, I'd have to flip the sign. How do I graph this? How do I graph this? On a number line? Christian?
You have negative 3, and then x is less than that, so it's going to the left.
Okay, what's to the left? How do I start it though? Do I put a open or closed circle?
Close. Open circle.
Why open?
Because it's equal, it would have to be less or equal to.
Yes. When it's less than or equal to or greater than or equal to, it means that negative 3 could be the answer. But this says that x is less than negative 3. So negative 3 is not in the solution set. An open circle indicates that this is missing in a sense, right? If it's a closed circle, it means that you can include negative 3 in the solution set. That would be when you have a less than or equal to sign, and you close the circle. Right? Questions on this? Pretty straightforward, right? Anybody know how to write their answer in interval notation? So here's our answer in solution set form, right? Here's our solution set. Anybody know interval notation? Have you learned this ever? Let me show you how to do it then. Interval notation pretty much tells you, give me a range of values. So where does the answer key or the solution set really start? What's all the way that way? Forever and ever and ever. What is the term? But specifically in that direction now. Negative infinity. So really, the possible answers are from negative infinity all the way up to negative 3. Any value, correct? So what we do is we put parentheses, negative infinity, comma, negative 3, close parentheses. It looks like a coordinate. It is not a coordinate. This is the solution set. The parentheses indicates a less than symbol, not a less than or equal to, or an open circle. If it's a closed circle, you're going to put a bracket. Again, a bracket indicates a closed circle. Parentheses indicates open circle. The reason I use parentheses next to infinity is because you really can't ever get to infinity. Use that logic. You can't get to infinity. You can get smaller and smaller and smaller forever. Infinitely, right? That's the whole idea. But you can't get there. So it's really like it's an open circle. So traditionally, mathematicians have adopted next to infinity to always use parentheses. Again, next to infinity or negative infinity, it's always going to be parentheses. On the other side, it depends on if it was an open or closed circle. Okay, this is called interval notation. The other one was called solution set notation. This is interval. We'll do one that is a little bit more tricky than just that. Solving graph. Now, I'm going to pause here because I've been noticing some people struggling with fractions. How do I get rid of a fraction when it's as a coefficient in an equation? Multiply by the denominator. Generally, though, you could always multiply by the reciprocal. The denominator works also, yes. But let's multiply by the reciprocal on both sides. The reciprocal of negative 3/2 is negative 2/3. So I'm multiplying by a negative. So I should do what? Emily? Flip the sign. Very good. Flip that sign. So I start with that already. Now, I know this is not necessarily maybe easy mental math, but you should know your thirds for things like 15. What's 2/3 of 15? 10. How'd you do that? Who answered that? How'd you do it so quick? You just know? Well, I could think of it as, what's a third of 15? 5, right? And then double that. So 2/3 of 15. Is that what you did mentally? Okay, yeah. That's usually what you do. Like, a third of 6 is 2. So 2/3 of 6 is 4. A third of 9 is 3. So 2/3 of 9 is 6. So you should know how to multiply things like this. If you didn't, you just simplify, right? Simplify this, and this becomes a 5. So you end up with 10. 5 times 2 gives you a 10. Now, I have a negative times a negative on the right-hand side, so that's definitely a positive still. On the left-hand side, I simply have r that's left over. This cancels with this. So r is less than 10. R is less than 10. How do I draw that in my number line? I literally do exactly what we did the previous one. Open circle, shaded left. What would this answer key or answer look like in interval notation? Use the same format if you're confused. Go ahead.
Negative infinity, 10.
Negative infinity, comma, 10. Okay, again. Solution set and this is an interval notation. Okay, interval notation. Yeah.
If instead of r is less than 10, if it was r is greater than 10, it would be regular infinity?
It would be parentheses 10, comma, infinity. It's always lower to greater. I was hoping this one would be an example of that, yeah. Hopefully, let me see what the next one. Did I do it in this one? Of course, the next one's not either. Great. Let's insert an example. 2x plus 4 greater than 12. God bless you. Greater than 12. I'd subtract the 4 to make that an 8. I'd divide by 2 to get x greater than 4. Shading, it would look like this. Let's do greater than or equal to, just for the sake of it, by the way. Close circle at 4, shade right. I always shade above the number line, by the way. You don't have to, but it's easier to see. If you shade on the number line, sometimes it's hard to see it. So, in this case, the solution set starts at 4 and goes all the way to infinity. So I start at 4 and I go to infinity. Oops, that's ugly. Now, infinity always has a parentheses next to it, because you can't get there. But 4 is in the solution set. So this is where I change that to a bracket, because it's a closed circle. Okay? So a bracket is indicative of a closed circle. Had this been an open circle, this would be a parentheses right here. Okay? All right. So let's get back to our time. little tricky, but you're going to notice something right away. Let's do this quickly. 12z minus 3 greater than 12z minus 10. Oh, look at that. 12z's on both sides. What happens? So we get negative 3 is greater than negative 10. Is that true?
Yes.
Yes, it is. Be careful. Negative 3 is definitely greater than negative 10. That is a true statement. So as a result, that means that if I plug in any number for z in these spots, it's always going to work. So the answer is all real numbers. Here's my solution set. Here's my solution set graphed. I could also just say all real numbers. In interval notation, what is all real numbers? From where to where? Go ahead. Yeah, negative infinity to infinity. Very good. That would be our answer in interval notation. This is the same thing as saying all real numbers. Questions? Okay, look at this one now. We've got 3 minus 2q plus 2 less than or equal to 5. I want to move stuff around. I want to subtract the 2. I get 3 minus 2q less than or equal to 3. Subtract the 3, I get a 0. So that's what I get. And I want to pause at this point, because you're still dividing by a negative in the next step. So although 0 divided by negative 2 is definitely still 0, what do you have to do? Got to flip the sign. Got to flip the sign. Okay, it's still going to be 0. That's the thing. And I want to make sure I go over this example, because so many people, they think, oh, but if it doesn't change the value over here, you have to do it. You still have to do it, because you're dividing by a negative. So q is greater than or equal to 0. Okay, there's our solution set. If I were to graph that, close circle, shade to the right. Interval notation from 0 all the way to infinity. Number 5. If we distribute the negative, I get negative 10 plus r is less than r minus 15. R's are on both sides as positive, so they can both cancel. Giving me negative 10 is less than negative 15. Is that true? It is not. It is a false statement. It is a contradiction. Therefore, no solution. Okay, you can do this also, remember? Empty set, or you can do this. Any of those work. Any of those work. All right, we're going quickly. I know. I wanted to get to this last. The last one says, why is the following statement true? Why is the following statement true? Inigo.
Because that means that A is a decimal, and when you multiply decimals, they get 1.
Exactly right. If A is greater than 0 and A is less than 1, for those conditions to be met on a number line, right, here's 0 and here's 1. It's greater than 0, but it's less than, hold on, it's less than 1. And in this range, it's all fractions or decimals.